Look at this image, our night sky's most recognized object, keeping time for humanity over millennia. But this familiar face is only half the story. The moon keeps an entire hemisphere permanently turned away from us, locked completely out of view. Out of sight, that hidden region has become a magnet for speculation. For decades, grainy telescope images and orbiting probes have sparked whispers of flickering lights, sharp geometric shapes, too precise to be natural, and massive objects casting strange shadows across the dust, which raises an obvious question. When you look at rooms like this, mission control centers that successfully coordinated dozens of missions across the solar system, why haven't they sent humans to our closest cosmic neighbor's hidden side? In an era where we land remote rovers on other planets, the long silence surrounding the moon's far side naturally makes people suspicious. To figure out why we haven't gone, we have to start by correcting a primary misconception. This diagram shows the Earth and the moon in orbit. Notice how the sunlight strikes both sides equally as the moon travels. The term dark side means visibility to Earth, not a lack of solar illumination. This untouched terrain is a direct consequence of physical laws and a massive geometric problem. The reason we never see that hidden hemisphere from Earth is due to a mechanical process called synchronous rotation. This top-down model shows exactly how that works. Imagine a dancer spinning, always keeping their chest pointed directly at you. The moon does the same thing. It rotates exactly once on its axis for every single orbit it completes around the Earth, locking the near side in our direction permanently. But look at the highlighted area. Because the near side is locked facing us, the far hemisphere points entirely outward, staring into the vast empty expanse of the solar system. This photograph captures the result of facing deep space. Without Earth to run interference, the far side has absorbed the brunt of violent cosmic collisions. For billions of years, it has become a harsh, dramatically rugged landscape, defined by towering mountain ranges and colossal impact craters. That extreme bombardment makes it a geological goldmine. The crust here is noticeably thicker and untouched by the ancient lava flows that smoothed out the side we see. It acts as an unspoiled, deep-time archive, preserving data from the violent early days of our solar system and the moon's initial formation. We have a pristine scientific record sitting right next door, completely hidden from our telescopes by the unyielding mechanics of its orbit. But just because we can't see it from Earth doesn't mean we can't fly there. The real issue is what happens the moment a spacecraft slips behind that curve. As this diagram illustrates, communication relies on direct lines of sight. When mission control sends a radio wave to the near side, it arrives in seconds. But send a signal to a ship on the far side, and that wave slams into solid rock. To fix this massive dead zone, you must position relay satellites in lunar orbit to catch the transmission and bounce it around the blockage back to Earth. Building, launching, and maintaining that secondary relay network adds immense layers of cost and technical risk. Space agencies operate on finite budgets, and every dollar spent bouncing a signal around the moon is a dollar pulled from somewhere else. And for decades, those resources have had a more pressing destination. Images like this one from the Martian surface show where the focus went. For the cost of setting up a lunar far-side communication grid, engineers could send rovers to Mars, a planet that actually holds the potential for discovering past or present signs of life. The extreme logistics of maintaining a signal through solid lunar rock create a hurdle that typically outweighs the immediate scientific reward. But math and logistics rarely satisfy the public imagination. By shifting focus away from the far side, space agencies inadvertently created a void. Because human nature despises an empty map, we filled that data vacuum with our own narratives. The lack of direct observation morphed into accusations of cosmic cover-ups, generating endless claims that the shadowed craters hide alien bases, ancient ruins, or remnants of lost civilizations. It's easy to write those stories off as science fiction, yet they reveal our inherent desire to poke at the boundaries of the unknown. We want the universe to be brimming with hidden architecture, precisely because we want more mysteries to solve. The internet thrives on sensationalizing those shadows, turning grainy images into grand conspiracies. But the cold physical reality of orbital dynamics and radio frequencies tells a much more grounded story. This heavily scarred hemisphere stands as a humbling reminder of our engineering limits, proving that the hardest frontiers for us to cross are sometimes the ones sitting in our own cosmic backyard.